The best fighter in the Pacific in 1941 was also the most dangerous aircraft its own pilots could fly. Not dangerous to the enemy, dangerous to them. The Mitsubishi A6M Zero entered the war with a kill ratio that American commanders refused to believe. Early engagements over China produced numbers so lopsided, 12 enemy aircraft destroyed for every Zero lost, that U.S. intelligence dismissed the reports as propaganda. They weren't. The Zero was real, and for the first 18 months of the Pacific War, nothing the Allies had could touch it. Then the kill ratio inverted. By 1944, American pilots were shooting Zeros out of the sky at a ratio of nearly 10-to-1. The aircraft hadn't changed, the engine hadn't changed, the airframe was essentially the same machine that had humiliated the best Allied fighters at Pearl Harbor, over Malaya, across the Dutch East Indies. What changed was that the Allies finally understood what the Zero actually was. In 1937, the Imperial Japanese Navy gave Mitsubishi an impossible specification. The Navy wanted a carrier-based fighter that could fly at 500 kilometers per hour, climb to 3,000 meters in 3.5 minutes, and sustain a patrol range of over 2,200 kilometers, all while outmaneuvering anything it encountered in a dogfight. No aircraft in the world could do all of those things simultaneously. Physics wouldn't allow it. The weight required for a robust airframe, reliable systems, and adequate fuel for that range was simply incompatible with the maneuverability and climb rate the Navy demanded. The chief designer at Mitsubishi, Jiro Horikoshi, understood this. He was 32 years old, technically brilliant, and working under a procurement system that treated his objections as obstacles rather than engineering inputs. The Navy didn't want to hear about trade-offs. They wanted the specification met. Horikoshi met it. He did it by making a series of decisions that each made the Zero faster, lighter, and more agile, and each one quietly loaded the aircraft with a fragility that would eventually kill the program and the pilots who depended on it. The Zero flew its first test in April 1939. It met the specification. It exceeded it in several categories. The Navy accepted delivery in 1940. Production began almost immediately. By the time the first wave of aircraft crossed the Hawaiian coastline on the morning of December 7, 1941, the Zero had already accumulated 266 combat kills over China against negligible losses. The pilots who flew it believed they were flying the finest carrier fighter ever built. On paper, they were right. The paper was the problem. Flaw 1 was the fuel tank. A conventional fighter in 1941 carried self-sealing fuel tanks. The technology was straightforward, a rubber lining around the tank that swelled on contact with fuel, closing any puncture before the aircraft could ignite. It added weight, roughly 56 kilograms per tank, on a comparable American fighter. Horikoshi couldn't afford those 56 kilograms. The Navy's range requirement consumed every gram of available weight. The Zero flew with unprotected fuel tanks. A single incendiary round from the right angle turned the aircraft into a torch. Pilots knew it. They flew anyway. Flaw 2 was the cockpit armor. There wasn't any. No armored plate behind the seat, no armored glass in the windscreen. The pilot sat in a lightweight alloy shell with nothing between his body and incoming fire except the airframe skin, which was 0.8 millimeters thick in places. This saved approximately 30 kilograms. It cost, by conservative post-war estimates, several thousand pilots who survived their aircraft's first hit, but not the second. Flaw 3 was the controls. The Zero's control surfaces used a conventional cable system. At low speeds, the response was extraordinary, light, precise, almost telepathic. Experienced pilots described it as an extension of the body. At speeds above 480 kilometers per hour, the cables loaded up and the controls stiffened to the point of near uselessness. Above 550 kilometers per hour, the ailerons locked almost entirely. The Zero could not roll effectively at high speed. This was not a secret. It was documented in the Navy's own technical reports by 1942. The fix would have required a complete redesign of the control linkage. The Navy chose not to redesign. Flaw 4 was the engine. The Nakajima Sakai 12 engine that powered the production Zero produced 940 horsepower. It was a reliable, well-engineered radial for 1940. By 1943, American fighters were entering service with engines producing 1,600 to 2,000 horsepower. The Zero's engine never meaningfully improved. Mitsubishi proposed 2 successor designs. Both were canceled for reasons that had nothing to do with engineering and everything to do with inter-service rivalry between the Navy and the Army, which controlled critical aluminum and manufacturing allocations. The Zero ended the war with essentially the same engine it had started with. Flaw 5 was the structural limit. The airframe was designed around a maximum load factor of 7G in combat maneuvers. Pull harder than that and the wings could separate. This was known. What was not widely communicated to line pilots was that combat damage, age, and hard carrier landings progressively lowered the actual failure threshold. Aircraft that had been in service for 18 months and survived multiple engagements sometimes broke apart under loads well below the design spec. The number of Zeros lost to structural failure rather than enemy fire is not precisely documented. It is not zero. Flaw 7 was the radio. Early production Zeros carried a Type 96 radio that generated so much interference from the aircraft's own electrical system that pilots routinely removed the receiver entirely and flew without communication. Formation coordination was done by waggling wings. This meant that the moment a Zero formation entered combat and broke into individual engagements, each pilot was completely alone. No tactical coordination, no distress calls, no guidance from ground control. Flaw 7 was the pilot. Not a design flaw, a systemic one. Japan began the war with approximately 3,500 trained carrier pilots, some of the most skilled aviators in the world, with 300 to 500 hours of combat flying time each. They flew the Zero to its absolute limits because they understood it. When those pilots died, and by mid-1942, at Coral Sea, Midway, and the Solomons campaign, they were dying faster than Japan could replace them. The replacement pilots arriving had 100 hours of training, sometimes fewer. The Zero was a precision instrument that punished imprecision with death. The replacement pilots were not precise. Subscribe if you want more of these. Japan's pilot replacement crisis is one of the least told institutional failures of the entire war. We're just getting to the part that decided it. In June 1942, a Zero made a forced landing on Akutan Island in the Aleutians. The pilot was dead. The aircraft was intact. Lieutenant William Thatch had already developed a counter tactic for the Zero based on observed combat patterns. The Thatch Weave, a 2-aircraft maneuver that used mutual cover to defeat the Zero's turning advantage. He developed it in 1941 before the war began, from intelligence reports the Navy had mostly ignored. The Akutan Zero gave American engineers something more direct: the aircraft itself, disassembled, measured, tested, and flown by American test pilots at NAS North Island by late September 1942. The report was 150 pages. Its conclusions were specific. The Zero could not roll at speed. It could not dive effectively. It had no pilot protection and no self-sealing tanks. The correct counter tactic was not to dogfight, never to dogfight. Climb, dive, extend, and re-engage from energy advantage. The Zero, stripped of its ability to turn and denied the close-range maneuvering that made it lethal, was a slow aircraft with a fragile pilot and a flammable fuel system. That report reached fleet commanders in late 1942. By early 1943, it was in the hands of every fighter group in the Pacific. The Japanese Navy had access to all of this information through captured documents, through the observable shift in American tactics, and through the testimony of surviving pilots who reported that Americans were no longer turning with them. The Navy's response was to ask Mitsubishi for a faster Zero, not a redesigned Zero, a faster one. Mitsubishi increased engine output by 150 horsepower and added a heavier propeller. The aircraft gained marginal speed and lost the one quality it still possessed, its extraordinary low-speed maneuverability. Horikoshi protested. He had been protesting for 2 years by that point. His team had produced designs for a genuine successor, the A7M Ripu, that addressed the structural, protection, and engine problems systematically. The Navy approved the A7M in 1942. They allocated manufacturing capacity to it in 1944. The first production aircraft flew in 1945. 8 were completed before the war ended. The Zero flew as Japan's primary carrier fighter until the last day of the war. The decision to keep the Zero in production while its replacements starved for resources was not made by engineers. It was made by a procurement bureaucracy that had committed to the Zero publicly, politically, and industrially, and could not absorb the admission that it was obsolete. Each year it remained in service, the gap between what the aircraft could do and what it was being asked to do widened. The pilots who flew it in 1944 and 1945 were flying an aircraft designed in 1937 against opponents flying machines designed in 1943, with less training than their predecessors and no protection if they were hit. They were being asked to win a 1945 war in a 1940 aircraft. Some of them understood this. The records of a few surviving pilots indicate they understood it precisely. They flew anyway. By August 1945, Japan had produced 10,449 Zeros, more of this single airframe than any other Japanese aircraft of the war. More than 1,000 were expended as kamikaze weapons in the final months of the Pacific Campaign, flown by pilots with sometimes fewer than 40 hours of total flight time. The aircraft, designed to protect the Japanese carrier fleet, became at the end a device for converting untrained young men into single-use projectiles. The last confirmed Zero kill of the war was recorded on August 15, 1945. The war ended that day. What the Zero story actually is, it isn't a story about a failed aircraft. The Zero wasn't a failure. For 18 months, it was the finest carrier fighter in the world, and it earned that distinction honestly. What it is a story about what happens when an institution mistakes the peak of a thing for the permanent condition of a thing. The Japanese Navy built a weapon optimized for 1941, fought with it in 1942, and then refused to accept that 1943 existed. Every flaw in the Zero, the tanks, the armor, the controls, the engine, had a fix. The fix required resources, time, and an admission that the current aircraft was inadequate. The procurement system could not make that admission. The pilots paid for it. 2 flyable Zeros survive today. One is maintained at the Planes of Fame Museum in Chino, California. It still flies at airshows. It is, by modern assessment, a beautiful aircraft. Light, responsive, extraordinarily well-engineered for what it was asked to be. What it was asked to be was a 1937 solution to a 1945 problem. If you want more of these, the institutional decisions behind the machines, the gaps between what was built and what was needed, subscribe. Next, the weapon that should have won the Battle of the Atlantic, and the command decision that made sure it didn't.